Writing equations of quadratic functions given the vertex and another point or 3 points. So there are 3 forms to a quadratic function. We have vertex form, intercept form, which is also known as factored form, or standard form. So with vertex form, this is useful when you have the vertex and any other point. And remember that your vertex is the coordinate h comma k, where h has the opposite sign. In intercept form, this is useful when you have both x-intercepts, and another word for that is zeros. And remember that the intercepts are p comma 0 and q comma 0. And again, p and q are opposite signs from the equation, but you also need any other point. This any other point could be the vertex. I just need, it doesn't have to be. You can have any other coordinate. And standard form is basically useful when there's 3 random points, and I actually have to use a system of equations to determine the values of a, b, and c. So standard form is not the most useful form of a quadratic function. So for example 1, it says, write the equation of the quadratic function shown below in vertex form. So we have to pay attention to what form it's asking us for. So we want it in vertex form. I need my quadratic equation in y equals a times x minus h squared plus k. So to figure this out, I need to find a, h, and k. H and k is very simple because that's the vertex. And so if I look at my graph, I know my vertex is here at the bottommost point. So the vertex has coordinates 2, -1. So my h is 2 and my k is a -1. If I were to plug that in the way it is, I would have a times x minus a 2, because it's always opposite signs and minus a positive stays a negative, squared, and then minus 1. That would be my vertex form. However, I'm missing this a value. I don't know what this is. This could be a 1, it could be a 2, it could be a 7. I have no idea. So what we need is another coordinate, x and y, to help us solve for a, to figure out what this is. So I'm going to pick any point on this parabola. So I'm going to pick this point up here at 4, 3. I'm going to pick that coordinate. So my random point is 4, 3. So what this is the x is a 4 and the y is a 3. When I substitute these in as well, I'm going to be able to have only a single variable left over. And then x is a 4 minus 2 squared minus 1. And so now with the vertex and a random coordinate, I have only one variable, and now I can solve this equation for a. So we're going to we're going to clean up the right-hand side. So 4 minus 2 makes 2. And then I'm going to do 2 squared, which makes a 4. Now I'm going to put the 4 in front of the a like this. We don't usually put our numbers in the back of variables. So 2 squared makes 4. And now I'm going to go solve for a. So I'm going to add 1 to both sides. And then divide by the 4 to get the value of a, which in this case happens to be a 1. So now that I have a, I can actually go back to this equation here and substitute a. So the final equation for this quadratic function is y equals an a value of 1, parenthesis, x minus the h, which is 2, squared, plus k, which is a -1. So this is the final equation for my parabola in the graph below. With equations, they always have an x and a y. We only plugged them in here to help us solve for a. So for example 2, write the equation of the quadratic in vertex form. So again, I want the answer in vertex form. So my answer is going to end up in this format. That goes through the coordinate -3, 1 with a vertex at -1, 3. So this is the same idea as example 1, it's just instead of a graph, I'm giving you a description. So we need our 2 pieces. So our vertex, be careful which coordinate you label as vertex. It says the vertex is at -1, 3. So this is your h, this is your k. The point that we have, the random point that this parabola runs through, is -3, 1. That's the x and the y. So pause the video, see if you can get the equation for example 2. Substitute h and k and x and y, solve for a, and plug it back in. And this is the equation you should have ended up with. When you substitute your y, your x, your h, and your k, solve it for a, you get a negative 1/2. So you plug in the a, the h, now remember it's minus and negative 1. If I do minus and negative, it turns to a positive. And then k is a positive 3, so plus 3. Now, for example 3, write the equation of the parabola that has zeros at negative 2 and 3 and passes through the point 2, 4 in intercept form. So now I want my final answer in intercept form. So intercept form was the x minus p times x minus q with the a in the front. So it's the same idea. I still need to solve for a. I have p and q because those are right here at negative 2 and 3. But I need the a value. So in addition to p and q, I also need a random x and y in order to help me solve for a, which I have an x and y right here at 2, 4. So let's box in our important pieces. Zeros at negative 2 and 3, so that means that p is negative 2 and q is a positive 3. Doesn't matter which one you call p and q, just make one of them p and one of them q. And then it passes through the point 2, 4, which is the x and the y. So if we go substitute this information, the y is a 4 equals the a value I don't know, parenthesis, the x value is a 2 minus the p value of negative 2. Notice there's double negatives. We'll clean that up in a minute. X again, which is a positive 2, minus a q, which is 3. Now that everything is plugged in, we're going to go solve for a. So we're going to clean the insides up. So 2, this is actually a plus. So a times 2 plus 2 makes 4, and then 2 minus 3 makes negative 1. I'm going to go ahead and multiply these two together. 4 times negative 1 makes negative 4, and again, I'm going to put it in the front because having variables at the front looks funny. And then to get a by itself, we're going to simply divide out the negative 4. So a is equal to a negative 1. So when we write our final equation, we're going to have y equals, y goes back to a y. A is a negative 1, x stays an x. Now, if we do minus a negative 2, that turns into a plus 2. And then if we do x minus a positive 3, that stays a minus 3. So this is your final equation for the parabola described for example 3. So for example 4, write the equation of the quadratic function shown below in factored form. So factored form is the same as intercept form. They're two different titles for the same form. So you want your final answer in y equals a times x minus p times x minus q. So you could choose any point on this parabola. The ones you have to have are the x-intercepts. These guys right here are p and q. So this one you can say p is negative 5. We can say q is negative 1. And then you just need to pick another coordinate. Make sure it's a coordinate that you know. Make sure they're whole numbers. Don't pick this one here because that's a decimal of some kind. Okay? So try example 4. Pause this video. And this is what you should have had for your answer. So I chose the vertex at negative 3, negative 2. This can be any coordinate. It doesn't have to be a random one. You can choose a special one. Even if the y-intercept had been a nice pretty number, you could have chosen the y-intercept as well. I wasn't sure if this was a coordinate, so that's why I did not choose it. I knew for a fact that this was a nice whole number. Should have had y equals 1/2 times x plus 5 times x plus 1. Now let's look at 5 and 6. We've written in intercept form, we've written in vertex form, now we need to write in standard form. So write the equation of the quadratic function that passes through these 3 points in standard form. So your final answer needs to be in y equals ax squared plus bx plus c. So the way we do this is we're going to use these coordinates inside of this formula as x and y, and we're going to use a system of equations to find the values of a, b, and c. So for the coordinate 1, for the first point, we're going to plug in negative 4, 6 into x and y. So what we end up with is 6 equals a times the x, which is negative 4 squared, plus b times the x again of negative 4 plus c. Well, negative 4 squared is equal to 16. And again, I'm going to place it in front of a. B times negative 4 is negative 4b, and then plus c. But for a system of equations, remember when we solve these guys with a matrix, this piece here is usually on this side. So we're just going to flip this around. 16a minus 4b plus c equals 6. So we're going to hang on to this for later. I'm actually going to highlight that in yellow. We're going to hold on to that. I need to do this 2 more times. I need it for each coordinate. So now we're going to do the second point. So point 2 is 2 comma negative 3. So again, we're going to plug this in for x and y into the standard form equation to get us another equation with a, b, and c. So we've got y equals, so negative 3 equals a times x, which is a 2 squared, plus b times x, which is a 2, plus c. So if I simplify, 2 squared makes 4, and 2 times b is 2b. And again, I'm going to take the equals and put it on the right-hand side. So 4a plus 2b plus c equals negative 3. So this is another equation. I have 2 now. If there's 3 variables, I need 3 equations. And so the last coordinate, point 3, is 0 comma negative 2. So the y value, y equals the a times x, which is 0 squared, plus b times 0 plus c. And we're going to simplify this one as well. Well, 0 squared makes 0a. We're going to leave that in there. B times 0 is 0b plus c. And then again, move this guy to the right. So 0a plus 0b plus c equals negative 2. So here is that third equation. So now that we have 3 equations, we're going to set ourselves up a system of equations in order to solve. So the first one we had was 16a minus 4b plus c equals 6. The second one we had was 4a plus 2b plus c equals negative 3. And the third equation we had was 0a plus 0b plus c equals negative 2. Now, we don't have to solve this by hand. We have a calculator that can solve a matrix for us. So if we set this up in a matrix, we have 16, negative 4, 1, and 6. We have 4, 2, 1, and negative 3. And we have 0, 0, 1, and negative 2. So now we're going to use our calculator to help us solve this matrix. So if we take our calculator, we're going to go to second matrix, move over to edit, choose A, and this is a 3 by 4. So 3, enter, 4, enter, and put in your numbers. So you've got 16, you've got negative 4, you've got 1, 6, 4, 2, 1, and negative 3, and then 0, 0, 1, and negative 2. Enter. Now we're going to quit out of this window. So second, quit. We're going to do the second matrix again. We're going to tell it what we want. We want the math. We want to go all the way down to RREF. Enter. And we're going to choose the matrix that we put this in. So second matrix and choose letter A. And press enter. So what this matrix solved is telling us is this is telling us that the A value is equal to 0.25. Because remember that this right here, this is the A equals 0.25, the B equals negative 1, and the C is equal to negative 2. So A is equal to 0.25, B is equal to negative 1, and C is equal to negative 2. So our standard form equation is y equals the A, 0.25, x squared, plus B, so it's really a negative 1x, minus 2. This is your standard form equation. Pause the video and try out example 6. And this should have been your solution for example 6. So you had one equation here, then here's your second one and your third one by plugging in each of the 3 coordinates into standard form, which gave you this matrix here. Solving this matrix with your calculator results in this matrix, and you have an A value of 0.55, a B value of negative 1.25, and a C value of negative 2.7, which results in y equals 0.55x squared minus 1.25x minus 2.7. Now, converting into standard form. So basically, we're going to take these 2 forms and we're going to write them in standard from their given format. So what we're going to do is we're going to basically expand this stuff out and make it look like y equals ax squared plus bx plus c. So if I notice in standard form there are no parentheses, so I need to expand out this squared. So when you have something squared, that means you're going to take that thing times itself. So there's really 2 of those x minus 3's multiplied together. Now, let's actually multiply everything out because I just have 3 terms. Right now I only have 2. So I'm going to start by multiplying these 2 things together here. So I'm going to do x times x, which makes x squared, x times negative 3, which makes negative 3x, negative 3 times x makes another negative 3x, and negative 3 times negative 3 makes positive 9. But I can't forget that we still have all of this multiplied by negative 2 in the front, and then drop the plus 4. So I have one more step of multiplication. We're going to take negative 2 times x squared to make negative 2x squared, negative 2 times negative 3x to make a positive 6x, negative 2 times negative 3x again to make another positive 6x, and negative 2 times 9 to make negative 18. So now that all the multiplication is complete, I no longer need parentheses, and all I have to do is drop the plus 4 and the y equals. So this looks a lot closer. I don't have parentheses here, and all my parentheses are gone here, but this is still too many terms. So we need to clean this up a little bit. So we're going to clean up by adding together the like terms that we can. So negative 2x squared, 6x plus 6x makes 12x, and then negative 18 plus 4 makes negative 14. So this is the standard form version of the vertex form from earlier. Now I do want you to notice, the a here was negative 2. The a here is still negative 2. The a values between the forms will never change. So whatever your a value is on the original, your a value will be for another form of the same equation. So pause the video, try number 8. It is already expanded for you. We need to start with the multiplication step. Here's your answer for example 8. So after multiplying the first 2 parentheses together, I actually combined like terms first to make it a little easier to multiply. Multiplying a 2 is easy for anything. Multiplying by a half is not quite so simple. So instead of distributing the half first, I added negative 3x and negative 4x to get negative 7x, and then distributed out the positive 1/2. That way I avoided having to add 2 fractions together at the end. Either way is correct, but sometimes cleaning up the inside first makes it a little bit easier to multiply the fraction in the front.